So in this video, guys, we're going to be solving basic sine and cosine equations. Of course, it's going to be way more complicated than that, but don't fear. We got a couple formulas for you here. It's going to make it much easier to figure it out. So let's go ahead. Let's just jump to one brief example. There's a reason to have the unit circle here, and we talked a little bit about this in the previous section, and I talked all about why we had the principal value, yet this whole area is like that goes out the window, and we're gonna have to write all the solutions. So going back to that example, when does sine equal 1/2? Well, let's go with square root of 3 over 2. That's a little more fun. So when does sine equal, and we'll go with negative square root of 3 over 2. So when does sine equal negative square root of 3 over 2? Well, it happens at two different places. Let's go with the first one. Let's go with 4 pi over 3. So we know that this solution, well, we would say theta equals sine inverse of negative square root of 3 over 2. And so then theta is going to be 4 pi over 3. Now this doesn't just happen here, but it'll happen 2 pi later. And then 2 pi after that. And then 2 pi after that. And then 2 pi, you get the point. So it's just going to keep going around and around and around. So I'm going to put plus 2 pi n, because I keep adding that circle to it, and I'm going to say that n equals 0, 1, 2, ... Just kind of continues that pattern of going up by the integers. Is that the only spot? No, it also happens at 5 pi over 3. And of course, you know, that happens every 2 pi. So when we plug our values into the calculator, it gives us the principal value, because you're not going to have these nice unit circle ones. You're going to have something crazy like this where we have to find sine inverse of negative 0.25. And I'll show you an example right now. But they give you the principal value. So how do you come up with the second value? So I have a couple identities for you, and that's the whole point of this unit, is the identities. Our first identity, one of my personal favorites, is cosine of negative theta is the same thing as cosine of theta. What this means is, let's just say you're solving cosine, you get theta is 70. Then theta is also negative 70. You know that the other angle will be negative 70. That will answer that equation. And like I said, you'll see some examples on this in a little bit. Sine, a little bit different, but also pretty simple. Sine is equivalent to sine of pi minus theta. Or if you're in degrees, you would say 180 minus theta, because obviously, you know, degrees, pi is the same thing as 180. So let's just go ahead and do this example, and I'll show you how this comes into play. So let's just say we have sine of x equals negative 0.25. Make sure we're in radians, so we're going to make sure our calculator's in radians. So solving this, we get x equals the sine inverse. And I should show you that step, the reason why we're doing sine inverse. So we have sine of x equals negative 0.25. So in order to get sine by itself, we have to take the sine inverse of both sides, or arc sine if you want to say arc sine. The reason why, these just cancel each other out and leave you with x equals the sine inverse of negative 0.25. And this n looks like an h. Let me fix that. So if I plug this in the calculator, it's going to spit out the principal value. And let me make sure I'm in radians. So yes, I'm in radians. We're good. Kind of interesting. But the answer to this one is negative 0.25 as well. So this equals negative 0.25. And since we're in radians, I'm going to add 2 pi n to it. And I'm going to say n equals 0, 1, 2, and ... Now, is this the only value? No. Remember, it happens at two different locations. We saw that here. It happened here, and it also happened over here as well. So it wasn't just in one spot. So what we're going to do, we're going to use this right here, that theta and sine of pi minus theta are the same thing. So I can take this negative 0.25, and I can do pi minus that. So let me do pi, I'm in highlighter, can't write in highlighter. So pi minus the negative 0.25. So pi minus negative 0.25 gives me 3.39. So our other value is going to be 3. Whoa, what's going on here? 3.39, and then of course plus the 2 pi n, because it's going to happen every 2 pi each time we go around the circle, and that's for 0, 1, 2, and so on. Now cosine, how does this one work? So for cosine, same idea, so I'll just skip to the good part. So we're going to say x equals arc cosine or cosine inverse of 0.35. And once again, we're using this inverse of cosine because this says cosine. Don't get mixed up and use arc sine or something. That would be a bad idea. So I'm going to punch that into the calculator. Of course, remember, it gives me the principal value, which is not the only value that it occurs at. So x equals 1.21 plus 2 pi n for n equal to 0, 1, 2, and so on. And where's the other value? Now, our identity this time is a little bit different. Negative theta and theta here. Cosine and negative theta is the same as cosine of theta. So it's actually really easy. We're just going to put negative 1.21 plus 2 pi n equal to 0, 1, 2, and so on. And the reason for this is because cosine of 1.21 is the same as cosine of negative 1.21, which would both spit out the 0.35. So with cosine, all you do is once you find the angle, that principal angle, just do the opposite of it, and that's the other one. For sine, you're going to do pi minus whatever that is, or 180 if it's in degrees. And that's it.